Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.121. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Ohm's law. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.121. Find the value of K in given below figure such that power supplied through 6 ampere source is 108 watt. This is the circuit diagram of given problem. Inside this network we have to find the value of this constant K. One information is given: power supplied through this 6 ampere source is 108 watt. Using this provided information, first we will find voltage across this constant current source. That voltage will be appearing across rest of circuit because all of these are connected in parallel connection. And in order to calculate voltage across this current source, we have two parameters. One is supplied power through this constant current source and other one is the amount of current through this constant current source. So using power conventional formula, that is the product of voltage and current, we can calculate voltage across this constant current source. So voltage across this source will be equal to power divided by the value of current. Value of voltage will be 18 volt and polarity of voltage will be positive terminal here and negative terminal here, because in order to supply power through this constant current source, current should leave from positive terminal and enter towards negative terminal. Now this same voltage with same polarity will be appearing across these all branches due to the parallel connection. So we can calculate individual branch currents because voltage across these branch are known and the value of resistances are also given. So first of all, current through this branch will be equal to voltage across it and the value of resistance 18 volt divided by 6 ohm. So current through this 6 ohm resistance branch will be 3 ampere and the direction of current will be downward. Similarly, current through this branch will be equal to 18 volt divided by 12 ohm. So the value of current will be 1.5 ampere and again the direction of current will be downward direction. Now the current of this dependent source is depending upon two parameters. One is multiplier K and other one is current I0. So in order to calculate its value, we should have both parameters. I0 is current through this 3 ohm branch, which can be easily calculated using current divider rule. But in order to apply current divider rule, we should have the value of current through this branch that will act as total supplied current. So first of all, we have to find this branch current. Later on, we will be able to calculate current I0 using current divider rule. So in order to calculate the value of current through this branch, we have to simplify this network. These two resistances are connected in parallel connection. So we have to find their equivalent resistance, that will be equal to the product of both resistances divided by their sum. So R equivalent of these two parallel connected resistances will be equal to 2 ohm and this 2 ohm will be in series with 4 ohm. So the total resistance of this branch will be equal to the sum of both resistances 4 ohm and 2 ohm, that will become 6 ohm. Total resistance of this branch will be 6 ohm. So current through this branch will be 18 volt divided by 6 ohm, that will become 3 ampere and the direction of current will be downward. This 3 ampere current will act as total supplied current for these two parallel connected branches in order to apply current divider rule. We will apply current divider rule for this branch to calculate the value of current I0, that will be equal to the product of opposite branch resistance and total supplied current divided by the sum of both resistances. So the value of current I0 will become 2 ampere. Now we will apply Kirchoff's current law on this node to further solve the problem. Write Kirchoff's current law equation for this particular node. On this node only one current is entering, that is 6 ampere, while rest of all other currents are leaving from this node. Entering current is taken with positive sign while leaving currents are taken with negative sign. And leaving currents are minus 3 ampere, minus 3 ampere, minus 1.5 ampere and minus K I naught. Add these currents together. This minus 3 ampere and minus 3 ampere will become minus 6 ampere. This minus 6 ampere and plus 6 ampere will cancel out with each other. So the equation will become minus Ki0 minus 1.5 ampere. Now place minus Ki0 on the other hand side of equal to make it positive and calculate the value of K. Inside this equation we know the value of I0 that we have previously calculated, 2 ampere. So replace I0 with its value. Divide on both sides with 2 ampere to calculate the value of K, that will become minus 0.75. So the value of K inside this network is minus 0.75. So this was exercise problem number 2.121. Thank you. See you again in next video.